All right, welcome to our video lecture series on Introduction to Computer Networks. Today's topic is going to be on the link layer. So, um, referring back to the TCP/IP model and the OSI networking model, as you can see, the OSI model has 7 layers, starting from the lowest layer, layer 1, which is physical, then data link, network, transport, session, presentation, and application layer. The TCP/IP, the first version, had 4 layers: link layer, internet layer, transport, and application. And as you can see in the figure, it also corresponds or presents you to the relation between the OSI and the TCP/IP model. The newer version, which is on the far right, has 5 layers, starting with the physical and data link, which is basically a breakdown of the earlier link layer in the TCP/IP model, and the rest of the layers are the same. So this lecture is going to cover basically the properties and the responsibilities performed and carried out by the link layer um, in networking. So the physical layer is primarily responsible for generating signals, and they are responsible for the actual transfer of bits between two network hosts or two endpoints. Uh, the physical media which are in consideration in the physical layer are could be optical fiber, coaxial cable, wireless media, etc. And no matter which form of media you're using, all of these would be facilitating the transfer of binary bits through some form of encoding and electrical characteristics. And then again, on the other end, the electrical signals would be decoded into the binary bits. In the data link layer, the responsibility is primarily to transfer data between two adjacent computers. It could be two hosts, it could be two routers, it could be a host and a router, but regardless of what the device is, it only is responsible for direct transmission of um, data through the physical media from one end to the other. And they need to be directly connected. So all interfaces in computer networks are identified by something that we call MAC addresses. Uh, the MAC stands for Media Access Control. So the media access control is what the data link layer primarily deals with, which allows you flow control, error detection during the time of transmission of these electric signals. Another thing that is important for the data link layer is the specific protocol data unit which applies to the link layer, and that is what we refer to as frames. So that means data link layer deals with frames and the transfer of frames between two directly connected and adjacent network devices. So the link layer receives the protocol data unit from the network layer, and it attaches the link layer header and the trailer, and together this whole thing is referred to as the link layer frame. And this is the whole frame which is transmitted over to the other network device through the physical layer and the physical media. So let's try to understand how a MAC address looks like. So MAC address is a 48-bit address. So 48 divided by 8 is equals to 6 bytes. And if you refer to the data representation if we have 6 bytes, that actually implies 12 hexadecimal digits. And the way that we can see here is that if we have a binary which looks like the top row here, it could be converted to the equivalent decimal values like this and the equivalent hexadecimal values like this. So the MAC address by convention is represented using hexadecimal digits, and there are 12 of these hexadecimal digits to incorporate the 48-bit address. The way these bits are organized, or these hexadecimal digits are organized, is that it has the first 24 bits, or 6 hexadecimal digits, allocated to what we call the organizationally unique identifier. And as you can see here on the table, these are just sample or like example OUI identifiers for different manufacturers. For example, Dell has the identifier 5C, 26, and 0A. Cisco has 2 of these, and Nintendo, Samsung, etc. So these identifiers for these manufacturers are fixed. They're allocated to each specific manufacturer, and they are fixed for any interface and any network device that these manufacturers are manufacturing. The remaining 24 bits here, or 6 hexadecimal digits, vary. So the result is that when a manufacturer is manufacturing, and when a manufacturer is putting out in the market a specific device, it has, or it comes with, this specific 6 hexadecimal digits, which refers to the organizational unique identifier, followed by 6 hexadecimal digits for that specific interface. And it could be a mobile device, it could be a network interface card on your computer, and whatever it is, it should be unique for each device that is being manufactured. So when we have network devices come with interfaces. And what we say is that each interface has a fixed and preset MAC address. For example, if we have a network host, it may have a wired interface or a wireless interface. So no matter what kind of an interface it is, it comes with a very specific and preset MAC which cannot be changed. It's a part of the hardware property. If you're referring to a network device, a dedicated networking device, which could be a router or a switch, so these have more interfaces. We generally refer to these as ports. So let's say this particular router has 6 ports, and each of these ports have a preset and fixed MAC address. And that is why MAC addresses, they are referred to as physical addresses. And they are tied to that specific interface, and it cannot be changed. So let's look at how the data link layer handles the transmission of a message from a source to another destination. So let's say a source would like to send a message to the destination, and the first thing that happens here is that the source sends it to D1's I1 interface. So D1 has 3 interfaces, and each of these interfaces have specific MAC addresses, and the source from its interface here sends the message to the I1 interface of D1 to this specific MAC address. Next, D1 collects the MAC address of D2's I1 interface, because that is the interface that D1 is going to directly send it to. So this direct connection will allow the message to be transferred or to be sent to D2. And once it is collected, D1 then sends the message to D2 directly to that specific interface I1. After that, D2 would need to forward it to D4. And for that, it needs to know that specific MAC address of that interface. So D2 collects the MAC address of D4's I1 interface and sends the message to D4. Next, D4 then would need to send it to D7, and the interface that is connecting D7 and D4 is I1 on D7. So D4 collects the interface MAC address I1, which is on D7, and sends the message to D7 through the I1 interface. Finally, D7 gets the destination MAC address and transfers the message to the destination through the direct connection. So what we saw here in this example are multiple direct connections. So the first one being from the source to D1, then from D1 to D2, D2 to D4, D4 to D7, and D7 to the destination. So there were 5 direct connections, and each of these connections required the MAC address of the interfaces, and the frame is then transferred with the help of the data link layer through each of these direct connections from the source to the destination.